Hi everyone, welcome to week 6, Algebra 1. So this week we are going to take all of our factoring that we've talked about so far and we are going to mix it in and start solving. So setting our equations equal to 0 and then factoring and finding out the actual answers for x. So our first one though, before we do anything, I just want to go through and review how to factor these three. All right, so for the first one, we're just factoring. There's no equal sign, so I don't have to figure out what it's equal to. So for this one, right, the leading coefficient right here, the 6, the leading coefficient has a number there. Okay, it's not by itself, so I can't use add and multiply, so I have to use the British method. So I'm going to multiply the first times the last. So 6 times negative 22 gives me a negative 132. And I need two numbers that multiply to negative 132 and add to negative 1. That looks like it's going to give me negative 12 and 11. So what I do is I plug that in. So negative 12x plus 11x, then bring down the minus 22 and bring down the 6x squared. Then factor by grouping. So I can take out a 6x, it's leaving me with x minus 2, and I can take out a positive 11, leaves me with x minus 2. So factored, this is x minus 2 and 6x plus 11. All right, so that was the British method. Looking at the next one, I have a binomial. So a binomial tells me that I'm most likely going to be doing dots, difference of two squares. This is 5 squared, this is 8 squared. So it's going to be 5x plus 8, 5x minus 8. That's not a very good box. There we go. All right, looking at the next one, once again, I have that leading coefficient and I don't have a GCF, so I'm going to have to use the British method. So multiply the first times the last, so 5 times 36. Gives me 180. So I need two numbers that multiply to 180 and add to 27. So that's going to be 12 and 15, both positive. So I'm going to break that apart, plug in 12x and 15x. Doesn't matter the order, you could do it the other way. You're still going to get the same correct answer. All right, go through factoring by grouping. All right, pull out a GCF here, so it's going to be an x and then 5x plus 12. And here I'm going to pull out a 3, positive 3, and that's going to give me 5x plus 12. So my two factors are 5x plus 12 and x plus 3. All right, for the next couple of problems, we're actually solving. So remember, to solve, you want to get all the terms on the same side of the equal sign, and you want your x squared term, or whatever your leading coefficient, to be positive. Then you look for a GCF if it exists. Factor the remaining polynomial, and then set the different factors equal to 0 to find out what x should equal. All right, looking at the first one, so you see that leading coefficient. I see it too. The only thing is that I can actually pull out a GCF. I can divide these all by 2. It's just going to make our numbers a little bit smaller. So it's going to be 2 and then 6x squared minus x minus 2 equals 0. Right, so now my numbers are a little bit smaller, so when I go through and I do the British method, I multiply to give me negative 12. My numbers are smaller as I'm going through doing factoring by grouping. So two numbers that multiply to negative 12 but have to add to negative 1 is negative 4 and 3. So break that apart. This is 6x squared minus 4x plus 3x minus 2. I'm just going to leave that GCF on the outside and just know that that's going to be in my answer later. All right, factor by grouping. Looks like I'm going to pull out a 2x, x minus 2, just kidding, 3x minus 2, and a positive 1, which gives me 3x minus 2. So my factors are 3x minus 2, 2x plus 1, and the 2 on the outside. Can't forget that 2 on the outside. Set that equal to 0. Last step here is I have to set all of my factors equal to 0 to find my answers. 2 equals 0 doesn't give me anything. This is going to give me a positive 2/3 because I'm going to add the 2 over and divide by 3. This is going to give me a negative 1/2. I have 2 answers. My highest exponent was squared, so it all works out. All right, going over to the next one. So this one's not set equal to 0, so I have to do that step. So I'm going to subtract over 243 to the other side. So now it's set equal to 0. 12x squared minus 243 equals 0. Now it's a binomial, so I'm thinking of difference of 2 squares, but as you can see, I don't have 2 squares here. So I'm wondering if I can pull out a GCF. And I can divide them both by 3. So if I pull out a GCF of 3, I'm left with 4x squared minus 81. This is a difference of 2 squares. I've got 2 being squared and I have 9 being squared. So leave the 3 on the outside because that's our GCF. 2x minus 9 and 2x plus 9 equals 0. Then I have to set my factors equal to 0. The GCF doesn't give me anything, so that kind of cancels. And this is going to give me, if you want me to actually go through and show the work, I'm going to be subtracting over 9 and then dividing by 2. So I'm going to end up getting a negative 9/2 and a positive 9/2 as my answers. All right, number 3. So once again, not set equal to 0, so I'm going to move over the 17x and subtract it. So it's going to give me 5x squared minus 17x plus 6 is equal to 0. Can't have a GCF, can't divide out the 5, so since I have a leading coefficient, I'm going to have to use the British method. So I'm going to do 5 times 6, which gives me 30. I need 2 numbers that multiply to 30 and add to negative 17. So that's going to be a negative 15 and a negative 2. 2 negatives will give me a positive 30, but when I add them together, I get the negative 17. So 5x squared minus 15x minus 2x plus 6 is equal to 0. Factor by grouping, group the first 2, group the second 2, pull out a 5x, leaves me with x minus 3, pull out a negative 2, leaves me with x minus 3 equals 0. So I get x minus 3 is one of my factors, and 5x minus 2 equals 0. Since it equals 0, my last step is that I need to set these equal to 0. So when I add over 3, I get a positive 3. When I add over 2 and divide by 5, I get a positive 2/5. Keep going here. All right, this one's a little bit longer. So this one, I'm going to have to move everything to the left because my leading coefficient, if I subtract 7x cubed over here, I'm still going to get a positive 7x cubed, which is good. That's what I want. And then subtract the 4x squared. That's going to give me a negative 13x squared. And then subtract over the 2x minus 2x. Okay, first step here, I can pull out a GCF of an x. Okay, leaves me with 7x minus 13, 7x squared minus 13x minus 2 equals 0. I can't divide anything else, so I have that leading coefficient. I'm going to have to use the British method. First times the last gives me a negative 14, so I need 2 numbers that multiply to negative 14, but add to negative 13. So that's going to give me negative 14 and a positive 1. So I'm just going to highlight my GCF here and then go ahead and use my factoring by the British method. So 7x squared, so minus 14x minus 1x minus 2 equals 0, but I won't even include that part. Group the first 2, group the second 2, pull out a 7x, leaves me with x minus 2, pull out a negative 1, leaves me with x. It's going to leave me with an x plus 2 if I pull out a negative 1. Oh, it's because it's supposed to be positive. Zoop. That's supposed to be positive there. So I'm going to pull out a positive 1, leaves me with x minus 2. Now my parentheses match. Awesome. 7x plus 1. Don't forget my GCF right down there. So that's an x. Set it equal to 0. Notice that my highest exponent here is a 3, so that means I'm going to have 3 answers. So when I set these equal to 0, I get my 3 answers. X is equal to 0 is my first answer. It comes from right there. Then positive 2, then negative 1/7. All right, I'm going to do a second video for the last 2, just because I don't want to run out of time. So I'm going to stop this video and I'll meet you at the second video.